Hi, welcome to this new video tutorial. We're going to see today how to build an interesting app regarding tracking the quality of the sleep. So the concept is using computer vision with a device, with a camera, we check ourselves at night, so the camera will be looking ourselves sleeping at night. And with this camera, we're going to see first where we are, if we are moving at night, how much we are moving and what's the position of the head. So the idea is to, at the end, when we end sleeping, when we woke up, we will see a graph telling us what we were doing, and also to tell us what's the quality of our sleep. The concept is that this app is going to tell us you slept well, you didn't sleep well. So let's start. A couple of days ago, I recorded a video of myself sleeping at night. So here we see the pillow, and the video is 7 hours 20 minutes long, from around 1 a.m. when I went to sleep till 8 in the morning. And if I go ahead, so we will not watch the entire video, but I will go really fast to see what we can expect. So here I start sleeping on the right side, so my right side is on the pillow, and as I go further, there are a lot of movements. So now I change the side, now almost frontal, and I keep continuously changing the side and moving the entire night on the bed. And this till the morning, so there is a lot of movement. So what are we going to do? We are going to track two things. One is the position of the head. So if I am on the right side of the pillow, on the front, on the left side of the pillow, or if I'm pretty much I have the head on the face on the pillow, so we'll see the back. So this is the first thing that we're going to track. Second, we're also going to track the position. So when the head is moving, so we will see a graph. When the head is moving, we will see like the heart rate graph, that we see something like this. We will do something similar for the head moving. So the concept, in my opinion, is that the more stable it is, the better is the sleep. So at least that's how I'm going to build the app right now. And by the way, to record this video, I use a Jetson Nano device. You can use either Jetson Nano or either a Raspberry Pi, because they have the night vision camera. So this is a night vision camera. You can see there is in the center the camera, then on the sides there are the infrared lights, so that we can see at night when there is no light. You can record also this with just a normal computer if you are willing to use a normal webcam, but you need to have the light on. So you can do this as long as the camera is able to see you. So if there is some lightning, probably that will be enough. We will not focus on the recording part. Instead, we will focus just on tracking the video, so the computer vision part. And if there isn't interest in this project, then we can develop it further. Just let me know in the comments if you're interested and if you have any idea about how to improve this project. So let's start analyzing the video. We'll start with an empty Python file where we're going to load, first of all, Opencv, so we import CV2, then we import NumPy as NP, which are the basic libraries for computer vision that we need to do image processing. And now let's load the video. Cap equals cv2.video capture, and I have the video which I call Sergio's sleeping.avi. And now let's show this video on the screen. So we're going to load the frames from the video while true, and we start taking the frames. So ret frame equals to cap.read. This one is giving us the frame in real time from the video, and this one is telling us there is a frame true, there is not frame false. So we need this in case, of course, the video at some point is going to end. So if there are no more frames, this will be false and it means the video finished. So in that case, we want to quit. So if the ret, so there are no frames, is false, we're going to break the loop. So it means that we are quitting. And then let's show the frame. cv2.image show frame and then frame. And now wait key event so that we can press any key during the execution of the video. cv2.wait key 1. If the key is equal to 27, we want to quit. So again, we break the loop as we did before. And then at the end, cap.release to release the video file. And finally, cv2.destroy all windows to close everything. Let's now run this one. Okay, this is the video. As you see, it is going so fast because we're waiting just 1 millisecond between each frame. So my goal is just to go as fast as possible to process all the information that I have that I want to see on this one. Now I'm going to load another file which I created, which is called head position. So using deep learning YOLO version 4, I created a file which detects the position of my head. We will not dive deeper into this one right now. Import, but I'm going just to import it and I will tell some more information during the video about this one. Import head position. So from the file from head position, we're going to import head position. HP, which stands for head position. And now from pretty much this file, this head position using YOLO version 4 takes the frame from the camera. So we give this frame, and in that frame tells what's in that frame. So for classes, if we have the front of the head, the left side of the head, the right side of the head, or the back of the head. So this is one thing that tells us, and also where is located. So we will get the coordinates of the rectangle to detect the head. Okay, so using this one, let's get head position. So we will use hp.get head position from the frame, and we're going to get ret, which will tell us if the head was detected. Then we will get the class ID, which will tell in which position the head is, and we will see this how it works. Then we will get the coordinates of the rectangle, so telling us where the head is, and finally also the center of the rectangle. So if ret, so if anything is detected, let's now show this. So let's now show the rectangle. cv2.rectangle. The rectangle, we want to show the rectangle on the frame. Then we have the position of the rectangle. So to draw a rectangle, we have 2 points. We have top left point and right bottom point. Here the box tells us these coordinates. So we will have x, y, width and height of the rectangle equals to box. So if we print them, let's see, we print x, y, w and h, and we run this. Now there is nothing, we don't see anything. Now there is the head, and we see, when there is the head, we see new coordinates. So x, y, width and height. So let's use these coordinates to draw the rectangle to see if the head is correctly detected. So cv2 rectangle on a frame. Then we have x and y, top left point. Then right bottom, x plus width. So top left x, y, x plus width. and y plus height. X plus width, y plus height. Let's make it for the moment green, so 0 blue, 2055 of green and 0 of red. We're using the BGR format. And now the thickness of the rectangle, we make it to 3 pixels. Let's not print anything anymore. Let's run this one. Okay, I see that the head is correctly detected. Now we see the rectangle is correctly following my head. Now that we have this, we need to know, okay, in which position is the head. So how do we know if the head is on the right side, on the left, front or back? To get this, we're going to get the class from the rectangle, from this function. And we have 4 classes. So class ID, if we print here, there is class ID. Let's print this one, print class ID. Just that you have an idea of what this is. Class ID is just an index. 0 is, it means the head is on the left side of the pillow. 1 is on the right side, 2 on the front, and 3 we see the back. So we see now 1. Then when I change the position, also this index is going to change. So 1, my head is on the right side of the pillow. So my right side of my face is touching the pillow. So let's take this information and let's show written on the screen if we are top left, no, not top left, left, right, front or back. So let's create class IDs, classes. We have the first one left, the second one right. This because I created the, I trained the algorithm using this order. Let's write front and back. So now we can put a text. cv2.put text. We put the text on the frame. Then we need to define what's the text. So we're going to get the text from the classes. So we take classes, and then from this class we have class ID. So if it's index 0, it will take text is left. If index 1, text is right, and so on. So here we put class ID, and then let's see what there is. Now we should have the position of the text. So let's place the text on XY, and now there is the font of the text. I will put 0, so we'll use the first font. The size of the text, let's use 1. Then the color of the text, let's make it green. 0 blue, 2055 of green, 0 of red. And now the thickness of the text, let's make it 2. And let's run this. Front, right. Okay, text is working, maybe some adjustments, so let's make it bigger and not overlapping the rectangle. So the text, so to not overlap the rectangle, we'll put it a bit on the top, so we're going to remove from the top some pixels. So minus 15, for example, and let's make it slightly bigger. And that should be enough. Okay, now while I am running this, we're also going to see the next steps that we are going to make. So in this head position class, I also added some different colors for different positions. So instead of showing everything green, we can show, for example, on the right side green when the head is on the left side blue, and two other different colors for the front and the back of the head, so that we can see in real time. For matter of visualization, it will be better for us. So there is no need to create 4 colors because I already created them in this head position file. So simply in this case, I will load the colors. So hp.colors, and here I say class ID. So I assign to each class a different color. I also want to change a bit of the text. Let's now run this. Okay, that's exactly what I wanted. So front, you see right is blue, the front is some kind of brown, I guess. And then the other side is green. So I'm not going to watch the entire video right now. Instead, once we have this, it's time for us to make what really matters. And now the thing that matters the most is tracking what's happening. So keeping a history of what's happening during the night, because now we're just displaying the information and not doing anything else. So first of all, let's track the position. So for how many frames the head is on a certain position, so that we can at the end say, okay, I slept 7 hours, for 1 hour the head was on the right side, for 5 hours was on the left, and so on. So we need to count them. So before the loop, I will create an empty array. So keep track head information. So we can say head position, and I'm going to make an empty array with 4 values. So it's not empty, an array with 4 values. The idea is to increase them each time. So if on the class 0, so on the left side, each time I am on the left side, I will increase this value. So +1, 2, and so on. Let's give an example. If we see let's say head position class ID plus equal 1, and let's now do this update head information, and now I'm going to print this one in real time. Print head position. So it will be more clear what's the goal and what I want to make. Okay, now I am on the right side. We see that the right side is the index 1. So each frame that I am on the right side, I am adding +1. So we know, for example, that till now I was never sleeping on the left side of my head, but I was like 296 frames on the right side, 15 on the front, and 7 on the back. So this one is already enough to get some information and to show a graph. So before adding the next, we're going to already plot a graph. So just at the end of the video, Now show, let's say, plot information, plot sleeping information, and then let's see how to do this. Okay, first of all, we need to keep track also of how many frames we had. We have information for. So each time total frames equals 0, because at the beginning we don't know yet. So each time we have a new information, we're going to add total frames plus equal 1. And these total frames correspond at 1 second of video, because I was recording just 1 frame per second, because otherwise if you record more frames per second per 7 hours, then the file will get really really big. So 1 frame per second at night when you are pretty much just standing, it's good enough. So total frames will be the seconds. Using this, let's now plot the information. So for this, we're going to load matplotlib. So we're going to import matplotlib.pyplot as plt. And now we're going to create a bar. So we will have 4 different bars, how long we were sleeping on each position. So plt.bar, we're going to put the 4 classes. So let's see, simply we just put classes, and then we're going to put the time, which now is in seconds. So head position, and that's it pretty much. Let's try plt.show and let's see what we get. So this is going to analyze, of course, to see all the information regarding the entire night. We need to wait the end of the video. So we'll just wait a few seconds just to see if it's working. So we will not have complete information yet. Okay. So now for 100 seconds, I was sleeping on the right side, for 20 seconds on the front, a bit less on the back, and nothing on the left side. So already the graph is working. We can, of course, improve this graph, but it doesn't really matter right now. Now, the second thing that we want is to track the movement of the head, no matter even if it's on front, left, right, so on. So we want to see where is the center, and we want to see if it's moving and how much it's moving. So let's quit and let's check this one. So to find the center, we have already the center here. So let's show the center on the screen. We're going to draw a circle. cv2.circle. We're going to draw the circle on the frame. Then we have center of the circle, which are the coordinates x and y. Then we need the radius of the circle. Let's make it 5 pixels. Then the color, we use the same function that we use for rectangle and text for the color. And thickness, let's make it 3. And let's run this and let's see if it's working correctly. We should see a circle in the center. And we see the circle. So the circle is the point that we are tracking to see the movement of the head during the entire night. How do we do that? Okay, the concept of this one is simple. We have the coordinates, so let's say 50, if it's 50, 50, and if then it moves somewhere here, it could be 40, 40, then we're going to see the distance between these points. So the distance between these points is the value that we are using to track the movement. So we see the position on this frame and the position on the next frame. So now update information. Here we need to get distance. Let's say distance. See center head movement. Get center head movement. So the distance. We have a formula to find this, the distance between 2 points in geometry, and in Python we can import the math library, and so math.highpot, and here we need to say x2 minus x1, so the x of one point minus the x of the second point, the y of one point minus the y of the other point. Now we have the center of the circle in this frame. What we need is the center of the circle in the previous frame to see if there was a movement. So we do it this way. Here we put center circle previous frame not to make it long, center circle center previous frame. Now we put 0 0 because we don't have anything, and so we check center of this frame. So we take x of this from the center, we take the x and y, so x and y. So x minus the center of the previous frame, 0 because the first value is the x, and then y minus the center of the previous frame, 1, the second value, which is the y. And also we need to update the previous frame because otherwise this will be always 0 0. Center previous frame equals center. So now the center in this frame, we're going to store it here. So when we go on the next frame, the loop starts again. Now we check this second frame, we check the center, and now we can find the distance between the previous frame, and it will be always this way because we store it one frame behind. And so let's see what is this distance. Print distance. I forgot to print the distance, and then distance. And let's run this and let's see if the value that we see is satisfying for us. Of course, the distance when we see it. Okay, when my head is almost not moving, the distance is just 1 pixel or almost nothing because there are almost no movement. When there will be a bigger movement, we should see a much higher number. So now we're at the end of this project. We're going now to store this information and also add a second graph to show the movement of the head during the entire night. So we can do it this way. Distance, of course, we need to keep track of this during the entire loop. So we will do the same as we did for the head position, head, distance, movement, and we will have an empty array, and each time we see a movement we add there. So if let's say head distance movement dot append distance, here we store the information. I'm going to add a comment store previous frame center, which is not store current frame center. And then at the end, we're going to plot the last graph. Consider that we already have one graph. We want to put two graphs together. So I'm going to use the function to subplot this. AX1 is the first graph. So that's how you do it in matplotlib. AX2 is the second graph, and then is plt.subplots 1 and 2, because we have two graphs. And then this one is the first AX1, and now we add the second graph, AX2.plot. Now it's not a bar anymore. I'm going to show just the classic graph where we will see like a line. So there is on the X, there is the time, and on the Y axis, there is the movement of the head. So if there is no movement, it will be a line. If there is some movement during the time, it will go up. So AX2 plot, we want to plot first of all the time, and the time is the length of head distance movement. So for each movement, for each second, we are adding the distance. So the number of the values is also the number of the seconds that we processed. So the length of head distance movement and then head distance movement. That should be pretty much. So let's try this to make sure that everything is correct. And I have an error. Okay, I guess I figured out the error. Here it is saying that on line 342, line 57, so this one, we have an array with 38 values and an array with just one. So the head distance movement must have the time. So there must be two arrays, and then plot, and I can run this. So pretty much I created an array which goes 0, 1, 2, 3 till the length of this, and then it divides everything by 3600, which gives us the hours. Oh, nice. Of course, at the beginning there is huge movement because my head was not on the pillow, and that's interesting. Okay, this is the graph. So now I will pause this video. I'm going to process the entire video of my 7 hours sleeping, and then we're going to take a look at the graph. Okay, here we are. Finally, I have the graphs, because we have two graphs. Let's focus now on the left graph. On this side, of course, we can put also the labels to be better to read, so to explain what's in the graph. But for matter of simplicity now, and not to make the project too long, I'm not putting any information. On this side, we have the hours that we're sleeping. So I was sleeping on the left side for less than 2 hours, sleeping on the right side for more than 4 hours. I was never sleeping, almost never, like less than half hour on the front. So on the video I was almost never on the front, and up to 1 hour on the back, so with the face on the pillow. And on this second graph we have the movement. So from 0 to 7 is the hours I was sleeping, and here we have the distance of the movement. So here is the higher the peak, the bigger the movement. So when there is almost a flat line, it means I was standing. Then if there is some peak, it means that I did a big movement with the head. Of course, this is a really basic graph that can be improved in many ways. For example, we can keep track also of not only the movement itself, but also the movement and also changing the position. we can also add the hour of the night. So here I have just 0, 1, 2, 3, 4, 5, 6, 7. We can add like 1 a.m., 2 a.m. so that you can calibrate it and understand what you were doing in that time. And there are also many other improvements in general that we can do with this. So before concluding, I want to say that this is an open source project. So you will find on the blog a link to the GitHub page where you can access to this project, you can download it, and also you can contribute to this project. So I will highly appreciate if you share ideas how to improve it, and if you can program, you want to take part in this project, it would be great to see you on board. So without adding anything else, I wish you a good sleep and see you in the next tutorial.